welcome back to Arxflix. Today, we're diving into an innovative paper titled Nougat, Neural Optical Understanding for Academic Documents. This research addresses the challenge of processing scientific documents in PDF format and converting them into a markup language, preserving the semantic information, especially for mathematical expressions. As you can see in this figure, Nougat uses a visual transformer model to perform OCR tasks on scientific documents, converting images of document pages to formatted markup text. Let's explore the main points of this paper. Scientific knowledge is predominantly stored in PDFs, which often lose semantic information, particularly for mathematical expressions. Existing OCR engines like Tesseract OCR excel in detecting characters, but fail to understand relationships like superscripts and subscripts in mathematical notations. Nougat aims to bridge this gap by converting document images into machine-readable markup text. It's a transformer-based model that doesn't rely on any OCR-related inputs, but infers the text implicitly. This allows access to scanned papers and books. Here, you can see the different types of image augmentation methods used during training, enhancing the model's robustness. Nougat's architecture is based on an encoder-decoder transformer. The visual encoder receives a document image, crops the margins, resizes the image, and processes it using a Swin transformer to produce embedded patches. The decoder uses a transformer architecture with cross-attention to generate tokens in an autoregressive manner. The model has 350M parameters and uses an MBART decoder. The document images are rendered at 96 dpi, resized, and padded to a fixed input size. Various data augmentation techniques like erosion, dilation, and Gaussian noise are applied to simulate document imperfections. An atom optimizer is used for training, starting with an initial learning rate that reduces over time. Since no existing paired dataset of PDF pages and corresponding source code was available, the authors created one. They used open access articles from Arxiv, PMC, and IDL datasets. The process involved converting LaTeX source files to HTML and then to a lightweight markup language. This figure shows the data processing pipeline from LaTeX source to Markdown. Nougat was evaluated using metrics like edit distance, BLEU, Meteor, and F1 score. The model demonstrated high performance, especially in recognizing plain text. However, recognizing mathematical expressions posed a challenge due to inherent ambiguities in LaTeX. This example shows how the model accurately converts a document page with many mathematical equations into LaTeX. A significant issue was the model's tendency to enter repetitive loops. To combat this, the authors introduced anti-repetition augmentations during training and developed methods for detecting such repetitions during inference. Using the variance of the logits signal for the detection of repetitions significantly reduced instances of repetitive outputs. The model does exhibit certain limitations like repetitions and performance issues with non-English documents. Future work could focus on addressing these challenges and enhancing overall utility. Nougat presents a promising approach for extracting text from both digital-born PDFs and scanned documents. It bridges the gap between human-readable documents and machine-readable text, making scientific knowledge more accessible. All the code and models are available on GitHub for those who wish to explore further. That's it for today's video. If you enjoyed this breakdown, don't forget to like, subscribe, and hit the bell icon for more content on cutting-edge research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.